Hello dear student, this is Deep Narayan Singh. In this video lecture, we are going to talk about bag of words algorithm. A definite question is being asked by the CBSE in final board exam. So this is the part of your unit 3, which is natural language processing. So first we understand the concept of bag of words algorithm. Then we are going to see questions based on that. So in this video, we are going to discuss only the concepts. One more video I will make separately what type of questions are being asked from this particular topic, that is called bag of words algorithm, TF-IDF. Let us see what is bag of words algorithm. So the definition itself, bag of words is a natural language processing model which helps in extracting feature out of the text, which can be helpful in machine learning algorithm. Now the point of difficulty is extracting features. So to what it is talking about from the natural language. Another point of difference is why they are calling it natural language. Okay, natural language and computer language. So there are these two things that we need to understand. Natural language are the language which are used by humans to communicate with each other, and they have the context and reference. Means same word can mean more than one thing in natural language, but in computer language one word have only one meaning and can only be said in one way. So this is the difference between natural language and computer language. Nowadays we can use natural language to communicate with the devices or computers. Okay guys, so to understand the natural language for any machine, it need to analyze it properly, that what is the context in that word is told. I have given example in my previous video where I have discussed the question on natural language processing that has been asked. So there I have one question has been asked, like give at least 2-3 state sentences where same word mean the different thing. So I have given the example of country's fair, that means गांव का मेला. अब that's fair, okay ठीक है, इसका मतलब ये है, but fair word is same. He deserted his parents is another statement, so it means उसने अपने parents को छोड़ दिया. Another one, he has taken dessert after his meal, same word desert means here sweets. So like that, this phenomena will not be there in the computer language, but this phenomena is there inside the natural language. Extracting features means, because in natural language, by reading it as a human being, as we understand the natural language, we can come to know that the text is written in what mood of the writer. Okay, so हिंदी में हम रस की बात करते हैं कि ये वीर रस की कविता है ना, इसमें शोक व्यक्त किया गया है. तो ये कैसे पता चलता है? ये डायरेक्टली भाषा में नहीं लिखा होता, बट उसको पढ़ के हमें ये आभास होता है कि इसमें कौन सा भाव सम्मिलित है. दैट इज कॉल्ड that type of information while you are able to get from a language, that is called feature extraction. Okay, we have studied a top paragraph and we can give a topic to that paragraph. So that topic is not written in the paragraph, but by studying that paragraph we can find out most suitable topic for that. So this is again called feature extracting. Okay, or in other words, to understand or to find out what are the meaningful words in that statement, because each word will not carry equal meaning in the sentence. So we will see later on in this video. Again we read this definition. Bag of words is a natural language processing model which helps in extracting feature out of the text, which can be helpful in machine learning algorithm. So for now you just remember this definition or read 2-3 times. That's it. You will get it later while I explain this algorithm called bag of words. Let us go. Bag of words gives us two things. What it gives? It gives the vocabulary of words from the corpus. Corpus is the text on which we are dealing. Okay, so we cannot take the infinite amount of text for our example. We need to take some text that has been generated in natural communicative setting. So while two people can be conversing in a written form or in a verbal form, so that communication can be taken as a text for bag of words example, and that is called what? Corpus. Corpus, वो टेक्स्ट है जिस पर हम अपने बैग ऑफ वर्ड्स को अप्लाई करेंगे या जिस पे हम फीचर एक्सट्रैक्शन निकालेंगे. द फ्रीक्वेंसी ऑफ दीज वर्ड्स, number of times it has occurred in the whole corpus. What is the meaning of frequency? Frequency का meaning है कि कितने number of times वो जो है word आपके corpus में आया हुआ है. So that means what? Frequency. Let us see the next note. Here, calling this algorithm as bag of words symbolizes that sequence of the statements or tokens does not matter, because whatever things you put inside the bag, there is no matter in what sequence you put, there is no value of the sequence. That's why we are focused on the words or sentences, not on the order, in what order those sentences are being said. So these tokens, words are also called here tokens, smallest individual unit which has some meaning. This is the definition of token. Again, we will read this note. Here, calling this algorithm as bag of words symbolizes that sequence of sentence or token does not matter in this case, as well as we need our unique words and their frequency in it. What is our objective? To find out how many unique words are present inside the corpus and how many times they are occurring or they are coming in the corpus. Let us go to the next slide. Steps of the bag of words algorithm. So what are the steps we need to follow while implementing bag of words? Text normalization means to reducing the complexity of the text, we change the text into the lower case. We do all those things which does not change the meaning of the text but reduces the variation in the text. So that step is called text normalization, and it will contain changing or making a similar case for all the data and removing the stop words, punctuation marks, lemmatization, stemming, all these things you might have studied in your text pre-processing, so I am not going to dig upon that. Moving on to the next step, that is creating a dictionary, making a list of all unique words occurring in a corpus, that is also called vocabulary. So we will list down all the unique words which are present in our text to which we are dealing in this bag of words. Okay, so that is called what? Vocabulary. Please keep that terminology in mind to understand it properly. Let us go for the third step, create document vector. So for each document in the corpus, find out how many times the word from the unique list of words has occurred. Okay, so you just remember the statement. While dealing with the example, you come to know exactly how to what they mean. Create document vector means in each document, or documents are the statement in the corpus, find out how many times that word from the vocabulary of unique words is occurred in that particular document. That is called what? Creating a document vector. And then that document vector will be created for all the documents. So that in itself is not a step, but it has to be done. Means creating document vector step will be repeated for all the documents. Let us go for the example, collecting the data and pre-processing it. This is also called a text normalization. So suppose this is our data. We have given like 3 documents. Aman and Anil are stressed. Aman went to a therapist. Anil went to download a health chatbot. So these are the 3 statement which has been given, and we have converted into 3 different documents. Here you can see document 1, we have pre-processed the data. So we find out that these are the tokens which are present. Here repetition you need not to consider. Okay, so whatever is present in the statement, you are going to write all of it. Okay, and because data is very small, that's why we are not going to remove any word out of it, otherwise meaning will be lost. Aman went to a therapist. Again, Aman went to a therapist. All words has been taken into consideration. In third also, we have bifurcated this sentence or into tokens. So these are the tokens which we get. Let us see this note, that no token have been removed in the stop word removal step. It is because we have very little data. Since the frequency of all the words is almost the same, no words can be said to have lesser value than the other, because very less data and words are not getting repeated too much. So all words will have the similar type of importance in the meaning of the statement. Let us go for the same example, and first step is completed, text pre-processing. Now our job is to create a dictionary. We have seen dictionary in NLP means list of all unique words occurring in the corpus. So we need to find out how many unique words are present in this corpus in all three documents and make the list. We are not going to repeat any word here. If some words are repeated in different document, they are all just written once while creating the dictionary. तो अगर कोई वर्ड बार बार कई डॉक्यूमेंट में आ रहा है तो आपको उसको एक ही बार लिखना है. Let us see there the dictionary. Aman and Anil are stressed, bent, download, health. Aman has not been written again because Aman, even though it appears in the document number 2 also, health, chatbot, therapist, A and 2. So these are all unique words which are present in this corpus. Okay guys, so let us see definition. Some words are repeated in different document. They are all written just once. While creating the dictionary, we create a list of unique words. So this is the definition of the dictionary. We create a list of unique words, that is also called vocabulary. Nomenclature you have to keep in mind. Next step, creating a document vector. So what is document vector? Document vector contains the frequency of each word of the vocabulary in a particular document, and it will be created for all the document. Let us see next. In a document vector, vocabulary is written in top row. Okay, fine. For each word in the document, if it matches to the vocabulary, put 1 under it. Okay, this is also fine. Two statement. If the same word appears again, increment the previous value by 1. And if the word does not occur in the document, put 0 under it. So these are the 4 statements, very important to create a document vector for any document. So we have how many documents? We have 3 documents, 1, 2 and 3. And we have a list of unique words in the vocabulary or dictionary. So these are the list of unique words which are present, and this is a document vector for document number 1. Okay, so Aman came 1 time, and came 1 time, Anil came 1 time, R came 1 time, stress came 1 time. Remaining all are not came in the document 1, so we have put 0. Now the same process will be followed for remaining 2 also. So let us see final creating a document vector table for all the documents, and this is the table which we get, because in first we will get Aman and Anil are stressed. Okay, so this is our first document. In second document we get Aman and, okay, so where is Aman went. So went is available here to a therapist. So this is second. Remaining what are all our words which are not present in the document number 2, we put 0 under that. Okay, so next one is what? In document number 3 you see Anil went to download a health chatbot. So Anil is present, went is present, to a and download health and chatbot. So like that you have created a document vector table. Once you have created document vector table, let us read out this text. In this table, the header row contains the vocabulary, obviously, of the corpus, and 3 rows corresponds to the 3 different documents. As we have 3 different documents in our example, take a look at this table and analyze the positioning of zeros and ones in it. So where we are going to put 1, if that word present in the document 1 time. So you see Aman is present in document number 1 time. If Aman came again in the same document, then we are going to increment the value by 1. We have discussed in the previous slide. Next, finally, it gives us the document vector table for our corpus, but tokens have not still converted into the numbers. This leads us to final step of our algorithm, that is called TF-IDF. Okay, so till now these words has not been converted into numbers, and now we are going to see what is TF-IDF. Okay, so I hope you people are getting up to until here. Let us go TF-IDF. What is the full form of TF? Term frequency, and term frequency and document vector table is same, inverse document frequency. So this is something different, I will tell you. Term frequency is the frequency of a word in one document, and that is what we are putting in the document vector also. Term frequency can easily be found in the document vector table. In that table, we mentioned the frequency of each word of the vocabulary in each document. So that same table can be considered for term frequency table. So this is what term frequency table, example of term frequency, and this table is same as previous slide table. If you have forgotten, just go and check out once again. This is the example we are dealing with. Aman and Anil are stressed. Aman went to a therapist. Anil went to download a health chatbot. So wherever that word coming in the document, we are putting 1. If it is coming 2 times, incrementing the value by 1, and each row corresponds to the document. So document number 1, 2 and 3. Let us move to the next slide. That is what document frequency. So document frequency is the number of document in which the word occurs, irrespective of how many times it has occurred in those documents. So you can see this Aman has occurred in 2 documents. So what is the document frequency for Aman? It is 2. But you can see and occurred only 1 time in 1 document. So what is the document frequency for and? It is only 1. So header row will always have what? Vocabulary. Aman has the document frequency as 2 and 1. In the same way, you need to calculate for all the different words, or for all the words which are in the vocabulary. All unique words are present in what? Vocabulary. So Anil came 2 times, and then you can say Anil is present in document number 1 and 3 also. 2 came 2 times, so as you can see 2. Went also came 2 times. A came 2 times. Okay, like therapist came only 1 time. Download came 1 time. Health chatbot for 1 time. So this table is called what? DF, document frequency. After creating this table, next job is to, we can observe from the table is document frequency for Aman, Anil, went to A is 2, as they have occurred in 2 documents, because they are present in inside the 2 documents. Let us go for next statement. Rest of them occurred in just only 1 document, hence the document frequency is for them is just 1. So rest of the word are only appearing in 1 document, that's why they are having document frequency as 1. Once you have created this table for the document frequency, we have created a table for term frequency previously, means that is same as the document vector table. Now our job is to calculate the inverse document frequency. Let us see how to calculate the inverse document frequency. In the case of inverse document frequency, we need to put document frequency in the denominator, while total number of documents in the numerator. So total number of documents, how many? We have 3. So our numerator will always be 3 and document frequency will be in denominator. Let us see. So Aman has the document frequency as 2, that is in denominator, and in numerator the number of document. How many documents are there in the corpus? 3 documents. Like that, for each word we will calculate. What we will calculate? Inverse document frequency. Okay, so we have calculated the inverse document frequency, and once we have get inverse document frequency and document frequency and term frequency, so we got all 3 tables. We got TF, which is equivalent or equal to the document vector table. We have calculated the DF, that is document frequency. We have also calculated the IDF, that is inverse document frequency. Let us go for the formula, that is TF-IDF. Now our job is to calculate TF-IDF. So TF-IDF of any word W will be the term frequency of W multiplied by the log of IDF of W. Okay, so inverse document frequency value will be put it inside the log and multiplied with the term frequency of that word. Then it is going to give us TF-IDF, means term frequency, inverse document frequency. Let us see. So this is what? This is our this color denoting TF. So this is what? TF. From here to here we have what? TF. And this is also called document vector table. Then we have what in next color, that is our DF. So this is what? DF, document frequency. And then third, what we have? IDF. Now we have TF DF and IDF, then we can put the value for each words, and W is denoting what? Vocabulary. So if you are calculating for Aman, then you need to put all the values which are related to Aman. Let us see. This is what? Our table of TF-IDF. TF-IDF. Here you can see for this particular cell, 1 is coming from the TF. This TF value is what? For Aman, that is 1. Multiplied by log of, what is the value of IDF? That is 3 by 2. So 3 by 2 is available here. Like that you need to put for all the vocabulary, okay, and for each document. So how many document we have? We have 3 documents. We have here in output 3 rows. Now this is the final output of the TF-IDF. Okay guys, let us see the formula of TF-IDF. If you have calculated those values in the final question paper, you can leave your answer at that place only. You need not to find out the actual values, okay. But here, as I am discussing this example, I have the answers available with me, so that's why I wrote here. You can see there some pattern is followed. Okay, what is that pattern? If a word is coming 2 times, it is having some similar value. If word is coming 1 time, it is having some similar value. Okay, so we will discuss about it, what these numbers actually are denoting. Very important. Next slide, analysis of TF-IDF. You need to have that in mind. Finally, the words have been converted to the numbers. These numbers are values of each document. Okay, here sorry, we can see that since we have less amount of data, words like are and also have the high value, but as IDF value increases, the value of that word decreases. So what does this statement means? As the IDF value increases, the value for that word is decreases. Let us see by this example. This is, for example, total number of documents if it in our corpus is how many? 10. Number of document a particular word like and is occurring is 10. Suppose हमारे पास 10 डॉक्यूमेंट हैं और हर एक डॉक्यूमेंट में एक शब्द है एंड जो आ रहा है, तो हमारा जो आईडीएफ बनेगा वो क्या बनेगा? द डॉक्यूमेंट फ्रीक्वेंसी विल बी व्हाट? 10. एंड हाउ मेनी टोटल नंबर ऑफ डॉक्यूमेंट? दैट इज ऑल्सो 10. सो 10 by 10 is equal to 1. And when you calculate IDF, okay, log of IDF, and that is going to give us 0. Hence the value of the end will become 0. As the curve is denoted famously, if frequency is very high for any particular word, okay, then the value for that word is less. As the frequency is higher here, so the value is very less. As the frequency is lower here, the value is higher for that particular word. So this graph denotes it very properly, and one of the question is asked about it in the CBSE board exam. I have also discussed in my previous video. तो अगर कोई शब्द हर एक डॉक्यूमेंट में बार बार आ रहा है, इसका मतलब है मीनिंग में उस वर्ड का वैल्यू क्या कम होगा, और ऐसे वर्ड को हम क्या कहते हैं? स्टॉप वर्ड्स कहते हैं. उनको हम पहले ही रिमूव कर देते हैं. लेट अस गो फॉर सम मोर एनालिसिस. ऑन द अदर हैंड, नंबर ऑफ डॉक्यूमेंट इन विच पॉपुलेशन आर अकर्ड मीन्स, अगर उसी कॉर्पस में एक वर्ड है पॉपुलेशन जो आउट ऑफ 10 ओनली 3 डॉक्यूमेंट्स में आ रहा है, then what is the value of IDF? That is 10 by 3. Okay, total number of document by document frequency, and that is going to give us value 3.3, and log of 3.3 will give us value of 0.522, which is way more higher than the word and, so it is more meaningful. So our algorithm is able to tell which words are having higher weightage in the meaning of the statement, and that is what we want, to actually find out the meaning of the text, which shows that the word population has considerable value of the corpus. Okay guys, so I hope you understood this analysis. Important points to remember about the this algorithm: words that occur in all the document with high term frequency have the least value and are considered to be stop words. ऐसे वर्ड जो हर एक डॉक्यूमेंट में आ रहे हैं, उनका अपने आप टर्म फ्रीक्वेंसी क्या हो जाएगा? ज़्यादा हो जाएगा, इस वजह से हम उनको क्या कंसिडर करेंगे, स्टॉप वर्ड करेंगे, क्योंकि उनका वैल्यू मीनिंग में कुछ भी नहीं रहेगा. फॉर अ वर्ड हैविंग हाई TF-IDF वैल्यू, द वर्ड नीड टू हैव हाई टर्म फ्रीक्वेंसी but less document frequency, which shows that the word is important for one document but it is not a common word for all the document. अगर आपकी हाई TF-IDF की वैल्यू है तो इसके लिए क्या जरूरी है, टर्म फ्रीक्वेंसी हाई हो लेकिन डॉक्यूमेंट फ्रीक्वेंसी क्या हो, उसकी लो हो. ओके, टर्म फ्रीक्वेंसी हाई हो बिकॉज टर्म फ्रीक्वेंसी सीधे मल्टीप्लाई हो रही है और IDF का लॉग मल्टीप्लाई हो रहा है. ठीक है, IDF का क्या मल्टीप्लाई हो रहा है, लॉग पार्ट. तो आपको टर्म फ्रीक्वेंसी तो चाहिए हाई, अगर आपको ज्यादा वैल्यू चाहिए किसकी, TF-IDF की, बट IDF की वैल्यू चाहिए लो, जिससे ये जो TF है वो ज्यादा बना रहे, उसे घटा ना पाए ये लॉग का मल्टीप्लीकेशन. इन दैट केस वो क्या दिखा रहा है कि उस वर्ड का जो मीनिंग है वो जो डॉक्यूमेंट में, उस वर्ड का वेटेज बहुत ज्यादा है. Let us see the third point. These values help the computer to understand which word are to be considered while processing the natural language. The higher value, more important the word is for a given corpus. Okay, जितना ज़्यादा हायर वैल्यू होगा TF-IDF का उतना ही इंपॉर्टेंट वो वर्ड होगा, तो उसको प्रोसेस करने में कंप्यूटर ज़्यादा से ज़्यादा टाइम लगाएगा. एप्लीकेशन क्या है TF-IDF की? देयर आर न्यूमरस एप्लीकेशन फॉर TF-IDF लाइक डॉक्यूमेंट क्लासिफिकेशन. बहुत सारे डॉक्यूमेंट जनरेट होते हैं किसी भी कंपनी में, अगर उनको क्लासिफाई करना है तो हम TF-IDF का यूज कर सकते हैं. टॉपिक मॉडलिंग, ओके, इट हेल्प्स इन प्रिडिक्टिंग द टॉपिक फॉर द कॉर्पस. कोई टेक्स्ट है आपको वेबसाइट से कहीं से उठाया है, उसका क्या टॉपिक हो, तो ये TF-IDF के थ्रू हम डिसाइड कर सकते हैं. इंफॉर्मेशन रिट्रीवल सिस्टम टू एक्सट्रैक्ट द इम्पोर्टेंट इंफॉर्मेशन आउट ऑफ द कॉर्पस. अब 1000 पेज का PDF है, उसमें से समराइज करना है, इंपॉर्टेंट इंफॉर्मेशन निकालना है, तो भी हम TF-IDF का यूज कर सकते हैं. स्टॉप वर्ड फिल्टरिंग, समराइजेशन, अगेन आई विल से कि ऐसे वर्ड्स को हटा देना जिनका मीनिंग कम है. हेल्प्स इन रिमूविंग द अननेसेसरी वर्ड्स फ्रॉम अ टेक्स्ट बॉडी. तो स्टॉप वर्ड फिल्टरिंग में अभी हम यूज कर सकते हैं. How to implement this algorithm inside a language? So as we are having Python language in our syllabus, there is a natural language toolkit library which helps us to implement this bag of words algorithm. NLTK or natural language toolkit is a Python package that helps us in natural language processing. It is a platform used for building Python programs that work with the human language data for applying statistical or natural language processing. So you have not much concern about it for this point of time, but let us see some more point. It contains text processing libraries for tokenization, parsing, classification, stemming, and tagging, as semantic reasoning, because these are all steps which we are doing while doing natural language processing. So for that, predefined libraries are available. You need not to write the separate code for it. All the NLP techniques that have learned in this session can be applied through Python NLTK package. Okay, and what is that package name? How to import it in your program? You need to write this command, import NLTK. I should be in a small case. Okay, so you need to write what? Import NLTK, and you will get all the functionality in your program to handle natural language. Okay guys, at last, this is our golden statement: arise, awake, and stop not until the goal is reached. Do watch this video before going for the solving the questions on bag of words, so that you are equipped with the concept of bag of words algorithm. Thank you very much for patient listening. Please do like, share, and subscribe this my channel if it is helping in your studies. Have a nice day.